started actually class number 12. And what I wanted to do was to share what I'm doing in the NetBeans here, so we can kind of see some other cool stuff going on. Okay, you should be able to see my NetBeans. Can you?
Yes.
All right. So one thing I wanted to do was go over an example here and see, and so you guys can see what the code looks like, and then we'll see what the code looks like, and we'll also see the solution. Okay. And the idea here is that when I go through the code, I want you guys to kind of understand that it should start to look a little familiar. The structure and the fact that you're defining objects and things like this. Okay. So this is a class in a package called animation. This is a class called animation itself with a capital A. These things are imported because I'm going to be using functionality from these libraries, right? It's already stuff you have to, extra stuff beside the language. You got to bring it in. You have a class. Now, do you both remember the whole light bulb state variables, right? The state of the light bulb. Do you guys get it?
I think so. Yeah.
Remember we had state on or off?
Like on or off.
Yeah.
Okay.
We just made this one.
So this one has two of those kind of variables. One's called X and one's called Y. Okay. And then inside, let's look at some other things before we actually go into the main. We're going to look at what this other stuff is. There's actually not very lines of code. There's probably less number of lines of code than you guys actually reviewed on the last class. Okay. Let's go over here and look at play right here. What the method called play. You call it. It does not return anything. Okay. It creates a JFrame, which is a Java frame. But basically, it means that I want to load like an application frame. Okay, and it's called frame. And then there's some attributes you can set to this frame to basically say when you close it, I want you to exit on close. This is probably not necessary to absolutely define because I think that's the default behavior anyways. So we'll test that out. There's another object here called draw panel, but draw panel is defined, user defined down here. We'll get into draw panel. So we have a interesting. You can define classes within classes if you did not know, but then this class is only visible within this class. Okay. And there's a class called draw panel. And this draw panel extends JPanel. Now the word extends, if you guys remember, means that draw panel is everything that a JPanel is plus the stuff that it defines. Okay, so anything that a panel can do. It turns out that in a console application, the kind of application that we were seeing where it comes out to the standard out, the like to the screen, the numbers down here. And then versus the stuff that comes out to an application, that when you're running like an application that popped up like an application window. Well, in the application window, there's also like another entry place. It's called paint component. Anyways, there's lots of events that happens, but when it first initializes, it's called paint component. And you can override this thing so that you can basically get access to the graphics object and you can do things. Like for example, you can, and he just made a local variable or a variable inside the method called G. This represents graphics, may not be named that well, but you can set the color. Now this is also there's some predefined colors in the system. This should look a little familiar to you, and I can tell by the way they're calling it that they've defined this in an enumeration. Remember, I did the enumeration with the different colors, and I had a similar kind of way of defining the colors. If we hover over that, maybe it'll tell us what the enumeration is. I don't know. know, but it might be some number. And then you can have it draw a rectangle starting at 0, 0, and then the width and the height of the window that's drawn, right? The height and width of the, let's say, application window. So, and what you can do is you can, it's saying to take the entire size of, take the, for the entire size of the window, then you're going to fill it with this color. Hope that reads a little bit all right. And then you're also going to then you're going to change the color again to a different color, and you're going to make an oval. You're going to make an oval at X and Y with 50, let me see, oval is how wide it is and how tall it is. So an oval that has the same height and width is called a, anybody? A circle. That's why it's called a circle. So there really is no fill circle thing. It's just a very fixed, defined oval. Okay, so basically, this thing, all it does is basically it takes the entire size of the window and then makes it white background, and then and then draws a green circle. It defines a green circle at X and Y. What is X and Y?
0.
0 and 0 when it's initialized. So it starts in the upper left-hand corner. It's a 50 pixels wide and 50 pixels tall. Okay, so it basically puts a circle. Can you guys imagine this? Right, it draws it fills the size of the screen with white, and then in the top left-hand corner, it puts a 50 pixel high and wide circle in the top left-hand corner. That's all this does. Okay.
And the oval is green, right?
And the oval is green. That's right.
Okay. Yeah.
So when we go back here, the reason I jumped over to draw panel was because it was called right here. I just kind of want you to know what it was doing at this spot. So here it creates a frame. It sets some default behavior on the frame, and then it defines this behavior of the background and the color of the oval. Let me see, get content pane. Let me see if I can, let me see if I can get a good definition here of content pane. So basically, this part of the call, so to add the objects that are defined by the draw panel onto the screen, you have to add it to the content pane. And the way you get the content pane is you ask the frames to give you the content pane. So you could have done, this could have been the same thing like this. Let's say, so see if that's an object. No.
Charlie's here.
Oh, okay, good. Anyways, to be able to draw those things that are defined by a draw panel, and actually put it on to basically say throw it on there, then that's what you do. You just have to kind of read and get that stuff. Okay. And then what it does is it takes this entire frame size and sets the maximum size, or basically the fixed size, for 500 pixels by 500 pixels. So that's basically the size of the window. And then it makes sure that you turn the, I guess, visibility, you want to make sure this turned to true. It probably is true by default. And then it does a for loop in here, and it uses I, and it says, so it's going to run through the numbers 0 through 150, right? Because then once it gets higher than 150, then this for loop's not going to work anymore. And it slowly changes the X and the Y value. So and when it starts at 0, it starts at 0. Next time is 1. So then X and Y are going to increment 1. And then it's going to repaint, which means it's going to redraw the screen. And now, one thing to note here, See this X and Y? Okay, these are locally defined variables for the animation. And when we say repaint, when I say repaint, what happens every time you hit repaint, then this paint component is called. So then it comes in here and what it does is if X and Y has different values, what does that mean? Then the oval, which is really a circle, is going to be in a different spot. So then when it comes around here and increments X and Y again to a new value, and then it says repaint, it's going to come over, and when it repaints, it's going to put the oval in a different spot. And really what happens with repaint, then it's going to come in here and it does this thread sleep for 25 milliseconds. You guys know what a millisecond is?
Millionth of a second.
No, it's a
thousand.
thousand.
I think, yeah.
Okay, so it's gonna sleep for just a little time, and it's gonna come around and it's gonna iterate, and then it's gonna keep incrementing X, Y. What do you guys think is gonna happen here? Anybody?
I think the circle's just going to move up and to the right.
Up and to the right? Well, you're close, but in the sense that you need to know that in graphic lands, 0, 0 is a top left-hand corner.
Oh.
and X positive X is to the right and positive Y is down.
Okay, well then it's going to be down and to the right.
It is. How many different places is it going to move?
150.
It's going to move 150 little places. So do you guys want to see what this thing does?
Yes.
Yeah.
That sounds really cool.
Let's see what it does. You guys see that? Yes?
No.
I don't see anything.
Okay, so it's probably because of the way the screen is shared.
Almost
So
just.
let me stop sharing here, and I think I need to share my desktop. And then I got to do this infinity thing. Okay, now you guys can see my NetBeans again?
Yep.
Okay, ready? Here we go.
Wow.
What do you think?
Very cool.
That is really cool.
Is that the beginning of something?
Yeah.
Yeah.
Okay, so that's like the beginning of something cool. Now, if you can imagine some of the early video games and things, this is way more complicated than much of the early video games. I mean, when you consider the quality of graphics and how to the effort it takes to actually make things move and things like that. So you do have this. Hey, Gavin, are you on?
Yeah, I'm here.
Okay. When did you get in? Are you got in about halfway through this?
Yeah.
Okay. Well, was that kind of cool or was it not cool?
That was pretty cool. How you animated.
Yeah, but the thing is you guys now know have enough skills that we can manipulate this thing, right?
Yeah.
Let's do something else. Let's take this. So this is the width. And this is the height. You can kind of see where a little bit of math could kind of get interesting at times. Okay, let's see what I did with this. Did you guys see that? Have a chance to see what I did? Everybody saw what I did?
You changed the color to red.
Yeah. And I also basically said what I want is well, I'm going to show you what happens, see if it makes sense to you.
Oh.
Okay. Okay, but I actually expected it to be in the top right-hand corner, and I didn't expect it to be off. So I must have the height and width backwards, probably. Let me see if this is what I was thinking. No, I wasn't thinking that either. So now I'm debugging because I was really trying to go to the top left-hand corner and come down this way. And let me see what makes it so difficult for me to understand that. So
Maybe it's the negative y doing that.
yeah, it could be. So I did have it moving. Oh, so it did move up instead of down, right?
Hmm.
So instead, we probably want to add y. And now let's see if it does anything else that's a little more interesting. Now it also started way the heck off the screen. Oh, I bet you if we did something like, is it off the, no, I don't know. Is it not off the screen? Okay. So let's say if, let's just start with a number that we can probably work out. Okay. Let's just do a number like 40 and see where this is. Because I think what it is just so far off the screen, I can't see what's going on. Oh yeah, there we go.
Whoa.
Whoa. Starting to look good.
Looks like planets moving. That's
You
what it
can
makes me think of.
Well, you can imagine having the ability to do stuff like make planets move and stuff. Okay. Okay. All right. So, actually, let's make it to where it sleeps a little bit when it first starts, so that we know we can watch it as we can. Okay. Oh, I didn't really mean to put a delay there. It's not the spot I wanted the delay. I wanted the delay actually to after it draws it once. Oh, actually, let's just make it go a lot slower. Okay. Make it go 10 times slower. Okay, then we can kind of see what it's doing here. So I obviously I've got this numbering thing. So it is going in the right direction that I'm thinking about, but it's obviously starting way more south than I was thinking. So that would be this number. Oh, I know why, because I think this should be actually x minus, and let's see if that fixes it. Oh, but then we got that negative number issue. Let's see, this would be, so as that increases, oh yeah, so let me see. How can we do this? So if we wanted it to be about the same, we had 120 minus x. If anybody can kind of get some ideas here. My problem is that I was starting way too low here. Let me just try another number just to kind of get in the ballpark, and maybe we can understand what's going on here. Whoop, it started way over south there. That's not what I wanted. Oh, I was thinking X and Y, and I've got to fix the Y. The Y is what I'm worried about. There we go. See, now I'm getting much closer. So now we have two objects, and look what they're getting ready to do. Okay. How about that?
So is the red going over the green because it was written after?
That is correct.
Okay,
Cool.
Yes.
that's nice.
That is what I thought you were hoping you would catch. Okay, now watch this. Oh, I guess I got to stop that, huh? Now watch it. Okay. Now it makes sense, doesn't it?
Yeah.
Yeah, that's pretty cool. So like this, the sooner you put it in the code, like it's gonna be more like a background to the
Right.
other objects.
Okay, now what would be kind of cool? What good is a game if you don't know when two things hit each other? Right? Collision detection. Think we can work on some collision detection together? How would we go about knowing if two objects have collided? This might be a little hard because we're not treating each oval like it's like an individual thing.
Yeah, that's what I was thinking. Because if we can make each oval its own variable, and we can say whenever the variables equal the same coordinates, then
Yeah, or that the area of them.
yeah.
That's exactly what you'd have to do. So you'd have to add more. You'd have to add your own thing. So watch this. If we did, what if we change this to x1 and y1? Okay. And we came over here and said x2 and y2. And then we reran it. We have the same solution, but now we can detect things. Why can we? Because they've each got their own identity. Okay, now let's do this. The problem here is that the raw x1 and the raw y1 are not the same. Not really the same. Because the object was not really at x1, y1, it was at some formula. So what I really want to do here is let's do this. Now let's see what we did. Okay. Now, wherever x1 and y1 is the same value of where the objects are. Let me show you that. Do you guys believe that? So we have x1 and y1 and x2 and y2, and it's the direct values right here about where the ovals are actually located. And it turns out that these x and y values is the top left-hand corner of the oval. Okay. Let me verify that actually. It turns out that it's the upper left-hand corner. That's right. This is the upper left-hand corner and upper left-hand corner, and then this is the side width and size. Now,
So it's not like the middle of it.
no, it's not the middle of it.
Oh.
How do we let's make a method. Oh, we're inside this class, right? This this class right here. Let's make a method, a public method that will return a Boolean to say collision detected. Okay. Now this one's always going to say false, right? But let's just finish this out here, and we're going to say We'll say console, or is it not console? It's system. System dot out dot right line. We'll say objects collided plus collision detected. Something like that. What did I do? Is that not how you do right line? Dot out dot print line. You guys should have caught me on that one. Okay, so what's going to happen is every time this gets done, it's going to tell you it's collision detected. But right now, it's going to keep saying false, right? You see all these bunches of false coming out on the screen? Yes.
Yes.
Okay, you guys do see it. Okay.
Sorry. Yeah.
Okay. So I do want you guys to participate here. We only got 3 students here, so you guys can just participate. Okay, so right now it's basically always saying that it's false, which is not correct, right? What will it take for us to determine if a collision is detected?
Basically, like
what?
an eclipse-like state, right?
Yes. What would that be?
Complete cover.
Okay, let's just say that let's only concern about let me see. So I'll put it this way, let me start you here. If x1 with, let's say, if x1, this is the left and right of one image, can I say that if x1, how can I draw this out for you guys? Let me do it kind of graphically here. Okay. Okay, let's say if we had a box that looked like this. And so if we had a box that looked like this, okay, and we're going to call this spot right here for one object is really x1, right?
Yeah.
Yeah.
Well, it's actually comma y. It's x1 comma y1, right? It's the top left-hand corner. And the width of this spot right over here is going to be x1 plus 50. Do you agree with that?
Yeah.
Mm-hmm.
And this corner over here is going to be y1 plus 50, right?
Yeah.
Okay, so what is this corner going to be?
Is it x2 and y2?
No, because remember the y1 and the y1, y2, x2 and y2 was the other object.
So is it x1 plus 50, y1 plus 50?
That's right. It's x1
Oh, yeah, that makes sense.
plus 50, comma, y1 plus 50. Okay, so those are the 4 corners. Now, what is the formula for knowing if something lives within that square?
Yeah, as long as it's the variables in between x1 and 50 and y1 and 50.
So is it enough to say if, let's see, we'll say if x2 is equal to x1, does that mean that it's in? Does that mean that it's in the box?
It means it's on the upper left-hand corner.
It just means no. It just means that it. Hey, remember, x goes left and right, and y goes up and down.
Yeah.
Starting in top left-hand corner. So if x2 equals x1, then that just means it's on the same row, and that it also means that that x2 could be way out here, correct?
Yeah.
Well,
Yeah.
x is left and right. So actually, in this case, I'm sorry. So x, it isn't that it could be there. It's that x2 could be here. Okay, is that true?
Yep.
So just because x2 is equal to x1 does not necessarily mean that x2, that point would be in that box. So what other criteria would it have to be?
It would also have to equal y to y1 in some way.
So also, you just have to say and. So you say and, which is this symbol, I guess, and, or just do one, and y2 equals y1. Now, this is true for this one spot. That would be completely overlapped with each other, right? Completely overlapped. But there's a lot of other points in here where it'd still be considered touching. Is that correct?
Yep.
Yeah.
Just one spot to one spot. So if that one dot right here was right here in the corner, that is true. It is touching, but there's a lot of other places it could be touching too. It could be true if y2 is, so it's got to be kind of like a between thing, right? So if x2 is, let's just write this out in a sentence here. If x2 is between x1 to x1 plus 50, and y2 is between y1 and y plus 50, then are they touching?
Yes.
Okay, that only takes care of if the x point is touching, right? That x2.
So
So
you
what about y2?
Are you asking us if x2
Yeah.
and y2 are in the box?
I'm saying is the point x2, y2, just one point of space, right?
Yeah.
If x2, y2 is anywhere in there, then that means that spot is in that box, right?
Yes.
Yeah.
Don't forget, we got a whole bunch, but the other circle is a bunch of other points. Okay?
Yeah.
So it is quite a bit more complex than this, isn't it? Because because it could be any point in x2. If any point in between x2 plus 50 and y2 plus between them is between the other. Now, let me see. I think there is, if I can find it real quick. They have already done, right? You can type in something like 2D collision detection formulas, and you could see here is the collision detection. Here's circle detection. Oh, this is for radius and stuff. We're actually working with squares, okay? And here is the formula. Okay, let's see if we could take this formula and put it, no, I don't want to, okay, let's put it in here. Let's put this formula in here and see if we can make it make sense. We're talking about rectangle 1, so this would be x1. This would be rectangle 2, so this would be x2. And then we've got rectangle, the width, which is 50. And we've got rectangle 1x, which is x1. And rectangle 1 width, which is 50. And rectangle 2x, which would be x2. Rectangle 1y, which is y1. Rectangle 2, which is y2. Height is going to be 50. Rectangle 1 height is 50. Rectangle 1y is y1. And this is y2. And basically, that is the if statement for determining whether collision detection, and if it is collected, what we're going to do is we're going to do return true. What are we thinking so far? You guys want to run it and see what happens?
Yeah.
Okay, let's see if that formula is actually right. Now, of course, you also have to watch the output as these things are running towards each other. Watch, I'll move it over here. Collision detection false. Now they get closer. We'll see if it turns to true. True, true, true. Oh, it was a little early. Oh, but it was also for rectangle too. So these things actually have a little bit bigger of a space than we're imagining.
Yeah, just an invisible box.
An invisible box. But is that that's pretty cool. We could refine this and get it working right. Did you guys see that?
Yeah.
Yeah, I
Do
did.
you need to see it again?
Maybe if we make that radius a little smaller.
Well, the thing is, if these were actually let's do these as rectangles. It'll probably make a lot more sense. Okay. Let's run these things as rectangles. Okay. Let's see if it makes more sense.
They can't see
Okay.
me. Not right now.
See that?
My mic was on. Hold on. Yeah, I saw.
Are you guys seeing this? How it's just saying collided equals true, 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 now false.
Yeah.
That's really cool.
It worked really good, didn't it?
Yeah, that was perfect.
Yeah.
It was perfect. So that was really what was happening to these ovals in the background, because remember a oval, even though it's only drawn in the center, its definition is bigger than that. So you'd have to do some different kind of math if you only wanted to include the drawing parts. Okay. Are you guys starting to see the potential here?
Yeah.
From here, it just gets to be where you can get things faster. And so we actually have a pretty simple game. We're not controlling it yet, but we actually have the ability to detect whether two rectangles have collided with each other. So normally in a game, what'll happen is as soon as you detect collision, you may have it change its behavior. Okay. So let's see if we can do that. I'm not exactly sure what's going to happen here. Haven't thought about it all the way around. But if the collision, if you can detect, oh, you can't do that there. I'm sorry. We have to do it in the graphics area. So if a detection is, okay, so here we go. Let's do, oh, how about this? If a collision is detected, then we will. Do you guys read code good enough to know about what's going to happen here? Guys, see what I just added?
Not
Yeah,
exactly sure what it's
saying
going to
that
do,
if,
but
if they detect a collision, then it's gonna turn the circle white.
One of them. Well, it's going to turn the rectangle because we define them as rectangles now.
Oh yeah, the rectangles now.
Okay, but only one of them because the other one's going to stay green. Let's see if that's true. Ready? We'll bring this over here so you can see the collision detection. Is it actually going to turn the red one to white? I think it did.
Oh, it looks like it disappeared now.
Right. So it looks like the green thing won.
and then it's going to
Wonderful.
show up again.
Yeah.
Okay,
All right.
that's cool.
It is kind of cool, isn't it? Okay. So, you can do another kind of, here's another example of a ball moving.
Whoa.
And as soon as it detects that it's at the end of the frame, it decides to change directions. Okay? It's fairly intuitive to see how this could possibly be done. Now that we have kind of figured out how to move things around. Okay? So what is this, with these examples, what do we think we can do that's something else that's kind of cool? Anybody got any ideas? Am I Pong? Yeah.
That'll be interesting.
You could do something like, oh, can you imagine, you know what? Let's just see if we can do, okay, do you guys know the game Breakout?
No.
No.
You guys don't know the game Breakout? Let's see here then. Let me see if I can. I'm pretty sure you guys have seen it. This kind of a game?
Oh, I've seen that before.
Okay, see these kind of games. Okay, so now that you know about how things move around, these are not traditional graphics of this thing. I don't know what they're doing here, but this is probably more of an original version or something. So what do you think is happening here? How complicated is it to do this?
It doesn't look really complicated.
I mean, as long as you have a ton of these squares,
Rectangles,
yeah, then you could say that whenever this ball here collides with it, then it disappears. It just turns the same color as the background.
Black. And then it turns out that if it collides with a square that is already black, then it's not detecting a collision.
Right, but if it collides with a square that's not black, it will.
It will detect a collision, and it also is detecting a collision with the paddle.
Right.
And if the y coordinate is actually larger, because remember it's top left hand corner 0, 0. If it's larger than that's past the bottom paddle of the screen, then it removes a life.
Right.
Is that pretty cool?
Yeah, it's a lot more simple than I would have thought.
It is a lot more simple than you would have thought. Now you take a look and you play a game like this, you would have never 12 weeks ago thought that you would have thought this was an easy game to develop. Is that true or false?
True.
Yeah.
Yeah,
so
that's definitely true.
You could do a very simple, These are I did this because there were some simple looking blocks. You know, you could easily make a game of Pong, could you not?
Yeah.
Now, how could you control the paddle?
I mean, you'd have to add some else elements into it.
Well, let's see if we can do like Java keyboard animation example. I think all you gotta do is capture a motion using the keyboard listener. You can use a keyboard listener. Let me see. Okay, here we go. So I think all I have to do is inside this right here is add another class. I get rid of all these little overrides here. Add for the key events. Add the import for the key listener. Now, I'm going to stop printing out the fact that it collides because we know this works. I'm going to run the program, but as I run the program, I expected the output here to show me that I was, let me see what's problem here. Key release, key pressed. Oh, key typed. Well, I don't want that one. I want a very specific arrow keys. Let me see. I want the arrow keys. Arrow keys example. Here we go. Oh. Okay, so let me see here. Oh, every time that's not exactly, I don't think that key event here. Let me see here. Typed. He said basically it is key event dot up and down. So I want left and right. Right. I want right for sure. Okay. So, oh, let me see. What was their example? This one right here. I'm going to go in here and I'm going to say there and I'm going to say paste. And he says, and I don't want up, I want right. And then then I will say system out print line press right, and then I can copy this. I bet you there's a VK left. Okay, and then I'm going to grab all this. I'm going to format the code. And then let me see. I don't think that is, I don't know if that's enough or not. Oops. Let me see. How do I call the event here? Let me see. There's got to be a little bit more to this. Oh, it's probably key pressed. Okay, let me see. Oh yeah, right. Oh yeah, I gotta close. I gotta close this one here. Oh, whatever. Still can't get my keys. I'm doing the left and right, and I'm expecting it to come out in the debugger here. It didn't. Let's see. I want to give you a working example so you could potentially. Oh, here it is. You got it included to add a key listener. How to add a key listener. It's a little more complicated than I was looking for here. Let me see. Scanning for the arrow keys. There's key press. We got all that stuff. Oh, here we go. Oh, implements key listener. Oh, okay, that's going to be the trick here. So I think what we need to do is I need to say that this class we do that. Oh, need to back it up here. Well, if we weren't browsing so quickly, I bet you we could figure this out. But I think you guys get the idea that, let me see, here's this one. There's not enough code here to actually implement yet. But if you could do the key listeners, then you can then you could change the direction of the object. Oh, look at this. I've got error right here. What's this error? What happened here? How can that be? Okay, let's get rid of our key listener. Oh, what's going on here? There, at least let's get back to normal here. Okay, so anyways, you guys can imagine doing the breakout thing. Basically, you would draw a couple of rectangles, and then if a detection was encountered, then matter of fact, you know what? So we don't even have to mess with the paddle. If we were to start with this thing, and we were to put a couple of rectangles in here, then we can make them come and go, and it could change directions if it detected it. Okay, let's see if we can get at least one of them in here. So we're obviously going to need to borrow this code because we need to detect collision. Okay. So let's see where we do all the drawing here. We need to do oh yeah, X1, X2. Well, oh, it's almost going to be easier for us to use the other one because of the X and Y's. Okay. Okay, let me see here. Okay, why is it complaining here? if I can do a. Okay, we're going to go back. We're going to go back to this animation. And let's see. Probably want to do. Oh, let's just add. As a matter of fact, we could kind of simulate this by doing this. Okay, we're gonna change it so that this one stays still and is gonna wait for the collision. Let's see if this works. Okay, so it does look like it works. And then we could say, if the collision is detected, then what we want to do is we're going to want to what we're going to want to do is change the direction for X2 and Y2. So one way to do that would be to add some kind of, I will call this R and T. Okay. Then what we could do is we could say, if the collision was detected, then R will be equal to uh, 2 times, we'll say -2 times X2. We'll say T is going to be equal to -2 times Y2. Okay, let's just see what happens here. I hope you guys can still see that. Here, I'll bring it over here. Oh, that's not what I expected.
So, was the red rectangle supposed to not be moving when it reached a certain point?
Yeah, the red one was not supposed to be moving, and it was supposed to turn white. But as soon as it turns white, I was expecting to change the behavior of maybe I just did it too quickly here. Let's just see here. I want to see what I'm doing mathematically here. So this is basically, this should shift it. Yeah, it made it bounce back like it hit it.
It bounced just a tiny bit though.
Yeah.
And then it started moving in the same direction.
Yeah. So One thing we could do this is to change the direction. I think we need to multiply it. I think I think this will change it. Hold on a second. That's not moving at all. Let me see. Oh, I see. Okay, let's see here. So as soon as it detects a collision, then it's going to should go back, basically almost retreat the same way it came. That's not exactly what I expected. Oh, you know what? Oh, it threw it off. Oh, of course it did. Oh yeah, of course it would do that. Let's see, what do I want to do? I don't want to do that. I want to do. I don't want to do that. So this would be addition. So there's a little bit more to this movement thing than just kind of throwing it together, huh? Let's see. Well, there is one behavior you can that we recognize we can do. It's kind of like a setback motion, right? Where if you hit it, it kind of bounces it back. There's probably all kinds of complex formulas you can do to create behavior. So anyways, there's a lot of things you can play with this thing for quite a while till you get something working right. Now, the whole goal here is if you get some kind of animation thing where you now have it generically defined, where you can reuse it, then you should reuse it. So probably on this collision detected thing, we should probably call it more accurately collision detected, like rectangles, right? Because it only applies to rectangles. And it probably should have a integer value x1, and it should probably have an integer value x2, and it should probably have an integer value y1, and an integer value y2, and also it should have a we should have a integer value x1 width, and we should have a integer value. So you get the point that now you could generically pass all these variables to it, and then because not all of your rectangles in every solution is going to be 50 wide. You know what I'm saying? Because it's quite a heavy assumption that your rectangle is always going to be 50. So if you make it more generic, where you could tell it dynamically your x and your y's and your of the two objects and their sizes of each, then it would be able to calculate the collision of two rectangles basically at any time. Now, it does also turn out, do you remember the example that we went through last time where we had a rectangle? The rectangle object, remember that one? Who did that? Was that Elijah?
The one with the, hold on.
Do you remember the rectangle? Do you remember the I'm going to stop sharing here. Do you remember the that example you gave that basically had a definition of a rectangles?
Yeah.
Now, it should be possible to pass two rectangles to this rectangle collision detection thing. Because if you pass a rectangle to it, you should be able to say what's your width, your height, and all kinds of stuff like that. So what was that object called?
Hold on.
Let me
So the rectangles?
yeah, it was called, what was the name of the object? It was called rectangle?
I'm looking at it. I think it was just rectangle. Like,
Rectangle R1, rectangle R2. Okay. And I think that if oh, good, it's not even actually complaining about this. Now this would be rectangle, oh, excuse me, this would be called R1 dot, that is it. So R1 dot X. Are you guys following this here? This would be the second one, 2 dot X. This will be R1 dot width. And this will be R1 dot X. This will be this will be R1 dot width. But this is actually R2 here, R2 dot width. This is X2, which will be 2 dot X. And this will be, whoops, what was that? Was that Y1? Okay, that'll be R1 dot Y. And this will be R2 dot Y. This will be R2 dot width. Is this kind of cool in retrospect here? This will be R1 dot width. And this will be R1 dot Y. And this will be R2 dot Y. Now, if you pass two rectangles to this thing, then you will, okay? So it turns out that what you need to do here I'll bet you I could do this. I'm just guessing here. Oh. No. Let me see if I could do this. Oh, let's see if I can do this. Rectangle R1. I bet you it takes all of these things. Oops. Oh, that's funny. Don't take one of those. I bet you it takes all these things. What is it complaining about? Expecting a semicolon. Oh, probably one of those. Okay. And then I'm wondering if I could just now pass the rectangle object to this. Oh, why not? Well, I know I can pass R1.x and R1.y and R1.width and R1.height. Okay. And I'm going to do this with, call this one R2, 2, 2. And then I can do R2, 2, 2, 2. And then after this is all done, oh, I'm going to have a problem here because the rectangle was not defined. Beforehand. Okay, I don't know if this will work, but it feels like it might. So let's see if we, so with just based on the example that Elijah gave us last class, and the fact that you can pass rectangles in and you can use them, and then he demonstrated how you could get all these attributes for the rectangle. Let's just see if we have now collision detection with rectangles. I have no idea if this will work. Well, it's not moving. So let's see, it's not moving because, because what moves is the x2 and y2, and then, okay, this one. So let's see. See if we can at least get back what we had. Whoops. Okay, there's x1 and y, but that is, it's going to create a new rectangle. I want it to create a new rectangle every time. Seems a little inefficient. Okay, let's see what it looks like here. So every time we go through here, we're creating a rectangle. Let's see if this one moves. Oh, look at that. Yeah, they sure do move. They move together now. I think what I needed to do was, oh yeah, these were minus, huh? Okay, now let's see if we've got collision detection with rectangles. Wow. Is that wow?
Yeah.
Was
Yes.
that was a pretty good segue from stuff you did, Elijah, isn't it? Showing you, because you were kind of showing everybody how, hey, you got this rectangle object, it's got all these attributes and things like this. Now we actually created a true rectangle collision detection with this. And you could, the thing is you could have developed something that wasn't as good as this, like we did before, and you would have we could say this here. Pretty well implies the type here, but you can and then improve it, and it gets better and better and better. And so, yeah, do you think it's possible to draw something that will change the size of the rectangles pretty easy? I mean,
You just have to change the variables.
Have to change the variables, yeah. Let's see. That's right. You just have to change the x and y coordinates. Let's see if it looks a little better. Maybe if we change it to something that's a little bit easier to see. Oh, wait a second. What am I got here? Oh yeah, that's of the that's the background. The first white is the background. This will be a little more visually obvious about, what it's actually physically doing while it's colliding. Okay. So We can, what I think we should do, I want to take a kind of, we're not going to have class for until January-ish. And I'm hoping that you guys will want to play around with maybe some of this or at least think of a simple game or something that we can start to develop with so that we can kind of see how things work. And you should be able to, kind of develop your own game. So basically your programming assignment is slowly building something. But what do you think we should work on? Maybe
I have a question
blockout
really
game?
quick.
Yeah, sure.
What happens if you have this as a problem? Hold on.
Oh, you want to show something? Do you have something to
My
share?
computer's not working. Yeah, my computer's not working
It's not?
anymore.
Okay,
No.
what kind of problem is it?
It's all green. It's corrupted.
It's green and corrupted?
Oh.
Yeah.
Well, is that the question? What do you do when your computer's green and corrupted, or?
Yeah, when it doesn't work.
What?
Well, it sounds like you kind of need to start it over.
Are you like watching on your tablet right now?
It's been, yeah.
Okay.
So,
Yeah, I've restarted it several
so
times.
probably what you should do is you should back up all the files that are on the computer that are important. That'd be pictures, documents.
Oh, I already did.
Okay. Then what you do is you find the instructions for factory resetting that computer, bringing it back to the factory default settings so that it reinstalls Windows and everything from the very beginning. What is the brand of the computer?
It's a Dell.
A Dell what?
Yeah.
Storing a Dell what?
Dell Inspiron 13 7000.
Inspiron what?
7. And then 7000.
Okay. So what you need to do is go to these in some instructions like this. So it says, if the computer is booting into Windows, please follow these instructions. It says, swipe your mouse on the top right to bring up the charms bar, which I don't know what that means. Settings, PC settings, scroll down to remove everything and reinstall Windows, and then click Get Started. What does it mean? What does the charms bar look like? Let me take a look here. I have no idea, but I bet you if you did this. Can you? Okay. It says they don't trust that way to do it. You could try that though, actually. Actually, that might not be a bad way to start. Do you have enough control over your Windows to go over and say, at least see if you can have enough control over your Windows to say reset PC? And are you using Windows 10? Okay, in that little type to search block area, type reset this PC.
No, I'm coming to you on an iPad. I mean, I can't turn. Like,
yeah, but you
is
should.
toast.
What's what is?
The video card.
Oh, that's something totally different. That's hardware.
Yeah, well, that's what I meant. Because
I
at the top, it's all cracked.
Oh.
I mean, I can turn it on for a short period.
Oh, it's your monitor that's
for a short period of time. Yeah.
Oh, so it's the monitor that's cracked. So it probably
really don't know how to do it blind.
Oh yeah. So what you need to do is on the side of the computer, you're going to see a place where you can plug in a monitor. So you should get another monitor and plug it in.
Oh,
and resetting the PC software-wise is not going to, of course, fix the monitor. And then you just use the computer like it's a desktop computer.
Desktop?
Yep. And I would plug it. You could plug a USB mouse and a USB keyboard into it, and just treat it like it's a desktop computer.
Yeah, that might work.
Yeah. So there you go.
Oops.
Okay, so let's get back to the question about what kind of programming do you think you guys can? Do you think we can start moving towards like a breakout game?
That would be cool.
That'd be kind of cool. And we
If-
can. What's that?
Oh, well, I'm just saying maybe like I think it'd be really cool to make a game, but I think it'd probably be better just to make something a lot more simpler like this. The
This
whole
is almost a game, though.
yeah.
Oh, I know. I'm talking about making it a simple like game like this. Yeah.
Okay. Well, if
It'll
it
use
was really simple, then
Yeah, if it's
then
gonna use these simple little rectangles and things,
yeah.
right? Something. No, it'll use simple shapes. So, over the holiday, do you think you guys can make enough where you could at least define maybe a top row and about 2 or 3 rows of rectangles by doing draw colors and draw whatever or something, and then and of course they're the same spot every time, so they don't even have to move.
Yeah.
And can you guys draw out and maybe and then we'll figure out how to add a ball and a paddle to it.
I think we
So I
could.
hooked it up to a monitor.
You did hook it up to monitor?
Yeah,
Did you fix it?
this is what I'm getting.
Or what are you getting? Oh, are you going to show me? You're showing me
It's
something?
the same screen as his laptop.
Yeah, nothing.
Oh.
Yeah.
So maybe. Does it still use the same video card
Oh,
whenever you do that?
yeah, that's that's kind of a video card issue. That's not even a monitor issue.
Yeah,
Okay,
and to
so
replace one of them,
well,
it's $200 to
let's boot it.
$400.
Let's power it off. Power off the laptop and then power it on. Yeah, hold down the power button or something. Okay. Okay, now turn it back on.
Did you like accidentally drop it, or did it just like show up like this one day?
See, that looks
It
good.
just did this after Windows Update,
Oh,
Oh.
okay.
Windows updated for me the other day. It
and
was
it
horrible.
does this. Yeah,
As soon as it
it's
updates,
been
it does
doing this
that.
for the.
That's the
Yep.
first thing it shows you.
Yep.
That's garbage.
Oh, what?
I'm gonna call
Well,
shenanigans.
now I'm not thinking that you've got a problem there with so let me see your laptop closer.
Okay.
Let me see. No, the screen part. Is it trying to tell you something? No, it's just blue.
Yeah.
Blue stripe. So go ahead and hold down the power button. Okay, keep holding it down. There you go. And now show me the monitor and then power it on.
Okay.
No signal. Check your source. You might have show me the laptop because this is way late. Okay, so while it's powering on, like let me see what the button sequence is here. Oh, let's see, what would that be? It was the Dell 7000 Inspiron, and it was a iOS keys. Let me see. So you're not even getting the Dell logo.
It does that a couple of times and it'll act normal, but it'll be super slow, and then it did this.
So power off the laptop again. Okay, now start pressing the F2 key like once every second and try powering it on. Like push the F2 key. See F2? Yeah, keep pressing it on and now turn it on while you're doing that. Keep pressing it while you're doing that. So power it on and go press the F2 key. F2, keep go press. Okay. You're not even getting the Dell display.
Uh-uh.
Wow. That means the
Yeah, I'm
BIOS is
pressing it.
messed up. Okay, that won't help now. Let me see here. Entering BIOS F2 when the Dell logo appears. Okay, so there's a function key. Do you see where it says FN? It's down on the bottom usually. It's usually
Yeah.
at the bottom by the space where you see FN. Okay, hold
Yeah.
FN down. Hold it down all the time, and with your other finger, press the F1 key while you're holding that button down. So yeah, hold down with your thumb, press F1. F1, not the F2, the F1. Okay, now you're going to do this operation the next time you power it on. Okay, so power it off.
Okay.
As soon as you power, get over there and hold down the FN key, and then press
Okay.
F1 and zip it over there. Okay, go. Function down and F1, F1. It was too quick. There's no. Okay, okay. Let me see what else there's selection here. What color is the screen? Is it kind of like a blue?
It's more of a green.
Hmm.
Oh. Does it follow this?
Wait, what is that on the
No.
screen?
Oh, this is a pen.
No, on the computer screen, it looked like there's like a little white dot.
Oh, this?
Oh, is that your mouse?
This is the mouse.
Oh,
Yeah, the mouse
it's a
can
box.
still function and
that's
stuff.
weird.
Oh, that
It's a
is weird.
box, though. That's
Yeah.
really weird.
What's weird though is you don't even see the Dell logo. Did you normally see the Dell logo when you boot it up?
Yeah.
Yeah, you did, and that's the part that's what's crazy.
Yeah.
Let me
Yeah,
see.
because it shows up on here, and you can move the mouse around and stuff, but here, let me try something. Oh. I'm gonna try doing it. I don't
Wait,
know.
did you get a different result there?
No, it's the same.
Okay, so here's what you need to do is remove the AC from it, the AC power.
There's no power.
Okay,
This is the cable that
there's no
connects it.
power.
No, no power.
There's no. How do you power? Oh, you're on a docking station.
Yeah.
Okay, remove it from the docking station. The computer. Okay, now it's free.
I gotta unplug this.
Now, okay. Okay, now power it off all the way as a standalone laptop. Okay, now power it on again, see if you get the same results.
Yep.
Okay, you do? Okay, so now go ahead and power it off and remove the battery out of the back. There's flip it upside down, and there's probably a place to remove the battery, right?
I'm gonna need a
Oh, it's one of those.
screwdriver. I'll be right back. I can go grab one.
You know where the battery is on that thing?
I actually watched a video. I can Google it real quick, but I think it's like maybe right back
Okay.
here in the Dells. So I'm just
Okay.
gonna go grab a screwdriver.
All right. This is crazy. So, anyways, Brian, Elijah, I think what we need to do is if you could get a block J panel going and draw some rectangles, maybe of different colors. And you make the first row like green, the second one red or blue, or however you want to do it. And just like present a couple of rows of potential for the breakout game.
All
You know
right,
what I'm
we'll
saying?
come back.
I'll
Between
see what I
them.
can do. I'll see
What's
what I
that?
can.
So we're,
Yeah, I'd
so
like to
we're
see how
like
far you
trying
guys
to
can get with that.
we're trying to copy the breakout game, kind of.
Yeah, same
Okay.
Maybe
row.
we could add some cool features later, but I want.
Yeah, just some very, very basic, just rectangles. Of course, they're not going to be squares; they're going to be rectangles.
Right.
And so, and what the thing is, once you define a block, you should be able to define a method that will, make the same rectangle size every time, and you just can reuse it, right? So you can make a class maybe called the block, and it'll basically return back to you everything you need to define the block, maybe something like that. Try not to, if you feel yourself keep writing the same things over and over and over and over and over, you probably means you should probably write a method for it if there's a way, if you think there's a way to do it. Now it will get power from that other thing that you plugged in. Is that true?
What is? Oh, there's a protective plastic
That's okay. Poke through it.
on this screw.
Yeah, just poke through it with your screwdriver there.
Maybe there's a way I can take it off.
Maybe.
Oh, here.
I bet not. Oh, take off the plastic. Yeah, yeah. We're definitely ready to dig into this thing. You're running out of options with a computer that behaves like this.
Yeah.
Was it? Yeah. Other question earlier, like, was it dropped or something, or?
Nope, never dropped. I actually barely even used this.
Is it brand new?
It's a year old, yeah.
Is it under warranty?
I don't know because it was given to me as a
Well, yeah,
gift.
I guess when you steal it, you don't get the warranty, huh? Yeah,
Funny.
is that true, Ryan, or not? If you steal it, because you've done this a couple times, right?
I've been able to return a couple.
Really? Oh, they still under the warranty if you stole it, huh?
Yep.
I guess maybe from Best Buy, but not Walmart, something like that.
Oh no, it's really Target. That's the area.
Target. Yeah.
Target.
Yeah. You want.
But really, though, I think you should just talk to the person who gave it to you because unless they bought a warranty around the same time they got that computer for you, then you're not going to have one.
Sometimes you can
worth more than 30 days.
Yeah, but you can usually type the serial number of the unit in to see if it's got a warranty, and they usually go by serial number.
I've opened.
Yeah, try not to scratch it up too bad. They're still screwing there? That middle one, yeah. They're still screwing that middle one, so unscrew that one.
There's a lot of screws in this.
I don't know why that is.
This one's loose, so.
That was why your computer broke. There's a loose screw.
Yeah, that's true. Probably a tab or something you lift up on it there. That's probably the spot right there or something. Yeah, it's starting to look funny. Well, one of the thoughts is that you basically.
Oh.
Yeah. What's the serial number?
I shouldn't have been screwed.
Let me see.
There's a service code.
Let me see if there's a way I could type in like your serial number or something and.
Yeah. Hold on a sec. I'm gonna put these screws back in here because I unhinged it.
Yeah.
And I just want access to the one thing.
Oh, you got a service tag number?
Yeah, he did.
Yeah.
What is that service tag number?
Service tag is B5Z DN52.
It says it's an Inspiron 7359.
Is it a 2-in-1?
Well, unfortunately, your warranty expired January 19th of 2017. That was all 12 months ago.
Oh, shoot.
Your warranty started October 21st, 2015.
That is true, because that's when I powered it on.
Yeah.
Got it into the States.
Oh, you smuggled it. That was a problem.
Charlie, why?
That's why he always goes by these alias. Yeah, and you really can't trust a guy that goes by Charlie.
There's too many Charlies out there. It's an easy disguise.
Yeah. Okay, Charlie.
Not that many Gavins, but there's too many Charlies.
For sure. So did you put those other ones back? Did you get the top off? Do you know how to remove it now?
Well, I figure once I get these loose, I can flip it over and the panel will kind of just fall out.
That's what you're thinking?
And yeah.
I hope so.
Let's see here. I'm going to see if I can find a video how to take off and replace the battery. Yeah, you kind of pry it up from the back. What I was thinking. Okay, you remove screws in the back, and then you kind of lift it up on its side, on the hinge side first, and then you just kind of pull it back and pop it off. Okay.
Is there any resistance? Or is it just going to slide
So what
off?
they did is flip it around, turn it around so that the back part's up. And then reach up, put it flat on the bed there, and then reach up and grab up in there in that area, and slowly pop it up and yank it back.
Can't really pop it up because there's no, it's like sealed.
I bet you there's some little secret trick on it.
Yeah.
What kind of computer was it again?
It's a
Dell Inspiron.
Which Inspiron?
The 7300.
13.
13.
13 inch, but 7300 series.
73.
No, 7300.
Okay.
So yeah, you're supposed to just pull the back off now.
Okay.
You got it now?
Seeing if I can get in the crack. Okay. Oh, I have an idea. I wonder if I put a screw in halfway and then try to pull it out using it as a...
Well, yeah, maybe, but it doesn't know because it doesn't screw into it doesn't screw in the back. It screws into the device.
Ooh, yeah, good point.
So let me see the corner a little bit better up there where you're trying to pry out.
Oh, you know what? I wonder if it... Oh, okay.
I think you see it?
I think I might have figured it out. Oh, wrong one. I think you have to do all of them because I think they all pop off as one.
What do you
But
mean
it
all?
looks like it's sectioned. Yeah, sorry.
Oh, the little feet.
Yeah. Here. I think because I put one screw back in, or a couple, sorry. I put a couple screws back in because I thought I was going to take off the whole thing and I didn't want to do that. But then I realized that it might all just be one and that this little seam is just how they cut it in the factory. Because I think once I get this one out, that it should... Oh, I hear clicking. This is kind of like opening up an iPhone.
Yeah. Well, your computer is pretty well useless now, so yeah, you're doing it. This is all right. That's right. You keep going. I see how it's separating.
Okay.
It looks right. Yep, this is looking exactly like the video now. Okay, on the other side too. Do it evenly on the other side. Yeah, you're getting in now. I can't believe you figured that out without even indoor plumbing. Now
We
he's
have
working on
indoor plumbing.
now he's working on computers. Look at him, guys.
Indoor plumbing costs too much.
Well, over in Montana, you don't know. You are way out in the sticks, though. I bet you it's nice and warm there.
It actually is pretty warm.
Well,
But
I guess,
what's warm for
It's
you?
been
yeah, warm is like
50.
not.
Oh my!
That is pretty warm. Yeah, that's pretty
For
warm.
me, I can't do cold. I'm sorry.
You
I
could
think
if you lived in
60
it.
is where I draw the limit.
Probably could if I lived in it, but I can't because I don't live in it. Never.
Oh, that was it.
Charlie, Gavin,
Why?
whatever your name
Oh,
is, what did you do?
what you doing?
Kevin, you're so close. I believe
Okay,
in you.
yeah, and your computer is useless with the way it is. So we're going to try to do is try to fix it because
Okay, class.
yeah,
Vivisecting computer.
yeah. So here's the deal, dude. You don't even put
Ooh.
that
Oh,
cover on. Don't even put that cover on until this computer is fixed. And where's the
Got it.
battery?
look. I think it's
Well,
big.
right here
It's the Dale
that
thing. Okay,
says
so get
lithium
that
ion
one.
battery.
Yeah,
Yeah.
see if it just picks up. Does it unplug somewhere?
Oh, there's screws in. Just want to make sure. Oh,
Or is
okay.
there a way to disconnect
Careful,
it?
don't
I
kill
just have to
yourself.
Hmm. Well, the reason is because what they say is they want you to maybe like to be able to disconnect the battery for a while and then let it discharge and then put it back. So because they one thought is that it's retaining some kind of crazy state, and it's like the hard reset is what this thing is.
That one's in there
Oh,
pretty
you
good.
know
I
what?
don't
No,
think I
fine.
have
No, show me closer on those screws. You probably got the wrong tool. No, that's Phillips. All right. But is there a
Yeah,
disconnect? Is there a disconnect reconnect?
it looks like right over here.
Oh, it slides in. Yeah, it
Looks
slides
like it
in.
just slides off.
Yeah, so once you remove the screw there, it probably slides out. You got a bigger
Probably.
screwdriver?
Uh,
There you go. Push down hard. Is that it, or are you stripping it?
no, it's coming.
Okay.
There we go. I probably
Pull back. Yeah.
slide.
Had it hung up somewhere else?
Oh,
Nope. Just grab it and pull it out.
well, there's this little bandage hook.
Okay.
Oh, that's not connected. Okay. There's just one other screw then, right next to the motherboard.
Okay.
So I just don't want to miss. Okay.
Yeah, now you should just be able to pull it straight out, straight back.
Oops.
Slide out of there, right? You're disconnected now.
There we
Where's
go.
it plug in at?
It plugs in right here with the blue tape.
Oh, okay. All right, good. So, that's pretty disconnected now. Now, see if it's possible for you to plug in the power source on the side of this thing without the battery in it. Or do
Oh,
you?
yeah. I'll go grab it.
Yeah.